something I've done for H, I, and J. But how do I do it for D, E, F, G, A, B, and C? How do I do it? Well, in order to obtain that for D, E, F, and G, I need to compute here in something called the backward pass. I need to compute to obtain what we call the late starts of every activity. The late starts are given in that corner here. Late starts. How do I get the late start of activity H? Knowing that the late finish is 50 for H, I'm going to subtract the duration of H from the total duration of the project. So 50 minus 15 is going to be 35. Okay, let's take a look at that. So it's explained here. Okay, I obtain the values here by subtracting this one from here. Okay, so I start from the late finish, subtract the duration of the task, and obtain the late start. Okay, so H can start at the latest on the 35th day. Why? Because if I add 15 days, I obtain 50, which is the total duration of my project. So what we get here, which is called, as I told you, we are in the late start. Well, the late start of H is 35 days. I compute the late start of I the same way. 50 minus 7 is 43. So late start of I is on the 43rd day. And let's start of J, 50 minus 21 is on the 29th day. So here I've obtained the, as I've told you, I've obtained here, I'm going to just summarize everything for you so to remember. That's the name of the task. That's the duration. Early start, early start, early finish, late finish, late start. Okay, so I'm going to continue like this, and I'm going to compute all the values for all my cells. So knowing, let me show you here. What is the next step? The next step is, now that I've computed here my late starts, the late start of every activity in the network becomes the late finish of every activity before it. If the late start of H is 35, it means D, that is right before, must finish at the latest on the 35th day. Okay. And then I'm going to continue in my network. Alors, same here. I will impose here 43, 43 minus 33. I'm going to obtain, alors here is, as I told you already, it's my late finish. I'm going to be able to compute the margins here. In 35 minus 9 is going to be my margin. But I'm going to continue before I show you how to compute the margins for everything. So I'm going to keep computing my late finishes and late starts. Okay, 43 minus 33 is 10, 43 minus 20 is 23, 29 minus 19 is 10, and here I've obtained for D, E, F, and G all my late starts. Okay, so 32, 10, 23, and 10. I keep going. Okay, same process. So here you are going to see that, for instance, C and B are followed by F and G. Okay, so we're going to have the same problem as we had before, but this time it's going to be reversed. Okay, what do I mean by that? B is followed by F, which has for value here is 23, and B is also followed by G, which has for value here 10. Okay, now this is a late start. Late start. It means that F can start at the latest on the 23rd day. G can start on the latest on the 10th day. Okay, so G cannot start after the 10th day. It means that B and C, which are antecedents, must finish at the latest on the 10th day. So you can see that this time the lower value of the two is the one constraining the predecessors. Okay, in that way, in that direction, it was the, if you remember, it was the highest value. When we go backward, it's the lowest value. Okay, that we'll see again. So the value of 10 here will be put here and here. It's not 23 because that's a late start, and the late start means at the latest, and G cannot be delayed. So I've got to put 10 and 10 here. Okay, that becomes, as before, the late finishes of all my activities. So the late finishes are 10, 10, 10, and I'm finished computing all my early and late starts. Okay, so how do I compute my margins? Remember, I did all that that I could find for every task what would be the total margin. Do I have some kind of security on that task, some kind of leeway, some float, or don't I have any? Well, let's compute that now. Okay. So how do we compute such a thing? Well, I started here from the beginning, but maybe it's a little easier to start from the end, as I told you before. Remember, I had put my 50 here, here, and here, and here, and I said I'm going to subtract those values here and see, 50 is when I finish my project, 24 is when I finish my activity, therefore H has 26 days of leeway, of float, and that's how I compute my margin. So I'm going to do that for every cell. Right, let's start from the beginning, like here. I have my here late finish. Sorry, I have my 10 minus 6, 4. I get we obtain total margins of tasks. It's written at the top here by subtracting the early finish from their late finish. So I'm going to subtract 6 from 10. 10 minus 6 is 4. Same here. I'm going to subtract 4 for 10. So 10 minus 4 is 6. Okay. I subtract the early finish from the late finish. And 10 minus 10 is 0. And I'm going to keep going like this. Okay. So 35 minus 9 is 26. 43 minus 39 is 4. 43 minus 13, and I move on. Okay, for every single task, I do that. And then I'm finished. I've computed the margins for all my tasks. Okay, so you can see that some tasks have a margin of a significant value, others have no margin or a margin of 0. Okay, they are here. We call the tasks that have 0 margin the critical path, critical tasks. Okay, here we go. I've highlighted here the critical path. All the tasks that have 0 margin are critical and are called, are said to be on the critical path. Now, the critical path, because it's so important, is defined as the longest path on the graph. Okay, and it corresponds to the group of activities that cannot be delayed without delaying the completion date for the entire project. There is always at least one critical path. There could be several, but there is always at least one. Okay. And on the network diagram, the critical path is found by following all the activities whose total margin is equal to 0. Okay, so that's what I just did here. At the same time, other activities have margin different from 0. You can see that H has a margin of 26 days. That's huge. Okay, same for D. Here you can be very late. It's not going to change anything. Let's move on with the presentation. Okay, so as I told you, activities C, G, and J are on the critical path. They cannot be delayed without delaying the entire project. Absolutely. That's it. All right, so activities B, H, and I are not on the critical path, and they can be delayed by 6, 26, and 4 days, respectively, as I told you. Those activities have some kind of security, float, margin, same word, same meaning here. Before I move on, I must introduce you another concept. This one is it's less widespread, even though it's well known in project management. But this last concept of free margin, okay, it represents the maximum possible delay of a task without delaying the start of the following tasks. Okay, so free margin is calculated by subtracting the early finish of an activity from the early start of the following activity. When there are several successes, the meaning of the early starts. Again, the free margin is by how much I can delay an activity, not without delaying the entire project this time, but without delaying the one that follows it. And the computation is fairly easy. You're going to see how to do that. So here, that's my free margin here. It's G, that is cell here. And how is it obtained? Well, it's fairly easy. If you want to obtain the margin of a task A, you take, it's explained here, you obtain the free margin of task by subtracting the early finish from the early start of their successors. For instance, for A, it's followed by D and E. So I take actually the lowest value of the successor if it's not the same value. Here's the same, so it's okay. If D had been 6 and E 7, I would have picked D, okay? Because D would have started earlier than E, but that's not the case here. So I do 6 minus 6 and I get 0, okay? That's the margin. What does that mean, the free margin of A? It means that if I delay A by more than 0 days, D will be delayed as well. So I have 0 free margin on A. It means that if I delay A, D will be delayed right away. Okay. How do I compute the free margin for B? Well, I do 10 minus 4 and I obtain 6. It means that 6 is by how much I can delay B without delaying F. Okay. It makes sense because B has to wait for C to, F has to wait and G has to wait for C to be completed, which will take 10 days. So in the meantime, because B finishes after 4 days, B you have freedom here. So that's how you compute it. Okay. So you compute that for the whole network. Okay. And so we compute everything. And we obtain all the free margins. Okay. So one thing I want to show you here, actually it's gonna appear here, is the free margin usually is either equal to 0. You can see here 0, 0, 0, or it's equal to the total margin. There's only one case, and there are only a few cases when it's not when it's not equal to 0 or to the total margin. There's only one case. So this one case is shown, here. It's in the case of F, okay? But it's very rare. So usually the free margin is either the total margin or 0, and in very rare cases it's different from that, okay? So you should be aware of that. Okay, very well. So we finish computing the free margin, and now when we look at the task on the network, we say, well, yeah, we understand what are the tasks that have kind of freedom margin in terms not only of whether they will delay the project or not, but now with the free margin, whether they will delay the task following it or not. Okay, so that's a very important piece of information on the network. Okay. Total margin is by far the most important, but free margin is also interesting to get. A final concept that will be explained here, it's called the critical path drag. This one is more rarely seen, but I personally believe it's very important when you do project management. It's basically by how much you can delay an activity that is on the critical